Hello guys, myself Ansar. So today we'll be doing a Python data analysis project of KCET data. KCET refers to Karnataka Common Entrance Test. Okay, first we'll identify a college or a university and three branches. Okay, next, extract the cutoff ranks for the general merit category for all the years. The years we have chosen is from 2016 to 2023. Next, we'll write a Python code to visualize the distribution of cutoff ranks for the given years. The next thing we'll do is that we'll fit a straight line to the data of each branch and plot. The final step after doing all these things, we'll analyze and comment on the trends of each branch. Okay, so let's start.
Now the first step is to create a project folder. So we'll go to downloads and I've already created a folder named DSF new where I'll be working on my project, and inside DSF new I have created a folder named KCET. Like it was a KCET data, KCET entrance test data. So I have created a folder in which I'll be saving my Python Jupyter notebook files and everything. Here I have the data, here I have the Excel data, whatever I'll be working on. So we can see the Excel sheet is like type of file is Microsoft Excel worksheet .xlsx. We'll also have CSV files, but the Excel worksheet which we are working on is .xlsx. So once the project folder and project location is ready, next we need to download and install. Next we need to download Anaconda Navigator. Type download Anaconda Navigator. It is a free software which you can download. So here if you click download, if you click download and then you can install it. So once it is done, you'll have an interface like this, like Anaconda Navigator, where we can launch Jupyter Notebook. Once you click here, it will be redirected to the Chrome and you will get a interface like this, okay, of Jupyter, and all the files, system files will be available here. So that we all know that we have created a folder known as DSF new in where downloads. So we'll go here, we'll click on downloads. You can see here we have DSF new. We'll click here. See, you can see .xlsx file like Excel worksheets. All the Excel worksheets are available here, and KCET. Okay, next I have already created a file, but if you want to create, here you have Python 3. Okay, and if you want to create a folder or text file or a Python file, you can click here. Next we'll click here and we'll go to the Python file. See, all the code whatever it was executed is available here. So coming to the analysis of the KCET data, the first and foremost thing we need to do is we need to import the libraries. So I have here, you can observe I have imported NumPy, Pandas, Matplotlib, Seaborn. I have also imported print function, curvefit. After this, the next step we need to do is we need to import the we need to load the data. Okay, I have already loaded the data. So this is an XLSX file. So the syntax for this remains like this, where the R indicates Unicode escaping. Okay, I have you can observe here, like the location what we have set previously is was in downloads folder DSF new. I have given .slxx and I have assigned it to df6. The same thing follows for each and every Excel sheet. The variable name only changes and the file names. Okay. So df6 here df6 means 2016, 2017, 2018, 2020, 21, 22, 23, and the final total for the total result analysis of all the branches and all the years. So after this, the first step I'll do is I'll take the first Excel sheet. I'll consider this sheet. I'll analyze this data. Okay, I have chosen three branches, like it will be civil, computer and electronics of the SDM college. Okay, after this you can see like I have chosen df6. So df6 dot shape, this is a syntax which provides in this particular Excel worksheet how many rows, number of rows and number of columns are present. Okay, next after this df6 dot head parenthesis. Okay, this provides the number of all the data, like number of rows and number of columns present, number of rows and number of columns present. Here I have nothing, I have entered nothing in the parenthesis, so it will give me 5 rows and we have 25 columns. We are working for only like only general merit category. Okay, I am working for only general merit category, so I don't need all these columns like 1G, 1K, 1R, 2AG, 2AK, nothing I need. So what I'll do is, this is the variable name what I have assigned. So df6 dot drop function is used to remove all the unnecessary columns which we don't require for the analysis. So I'll type the names 1G, 1K, 1R, 2AG and so on, except GM because I need general merit category. Okay, after this pressing shift enter, see here you had 1687 rows and 25 columns, whereas here you can observe we have, like after this drop we have only left with two columns. One is the branch, another is the general merit category. Okay, this is viewed with the df6 head function. Next, in the Excel sheet I have chosen like see here you can observe in the next line I'll show you this particular line. Okay, above this whatever data I don't need. So what I'll do, I'll use again the drop function using index from 0 to 271. Means 0 will be included, 0th index number will be included, that row will be deleted. When we select 271, it will delete the 270th row. Okay, so see after using this we'll again see here we had 1687 rows, whereas after using this drop function for dropping of the rows, we are left with 1416 comma 2, like 1416 rows and 2 columns. Next, again when we view, you can see I am left as I had told, till 270 to 270 will be dropped off, whereas 271 will be there. So see 271 I had viewed the Excel sheet, so this is 271, 272, 273. After 275 we have 276 plus electronics. So from 277th onwards we don't need the data below, all the data we don't need up till 1416. So there is a twist here, like I want to tell that here we mentioned 0 to 271, it's fine, but when we see this data, we think it's from 276. I had told it will be from 277 and till 1416, but that's not the case. Here the index number are assigned from 0, 1, 2, 3, 4, 5. 5 for electronics, and from 6 onwards we don't need. So what I will do, again I will drop all the rows. DF6 drop DF6 dot index from 6 to 1686. Actually I had to put 1416, I had entered 166, no issues. After that we'll be left with, see here, going to the next line, we'll come to the previous line only. 1 2 3 4 5 6 including electronics. We should be left with 6 rows. That's what happened here. You can see after using DF6 order we are left with 6 rows and 2 columns. To weave this, again the same function. See, in this I don't need this 271, 272 and 274. This is index 0, so I'll use this syntax and I'll delete. Okay, then see, it was 6 rows, now it became 5 rows. This line went off. Okay, next I'll do, again it will be 0 only, it will not be 1, it will be 0, because once the output we have got, it will be next assigned index number will be 0 1 2 from first onwards. Okay, next we'll left with 4. I have chosen civil, computer and electronics, so I don't need chemical. I'll drop off 0 1. Okay, I have used 1, so I'm left with this. Next I'll be plotting a scatter plot. For this the syntax will be plt.scatter data name is df6 x. In the x-axis I need all the branches, and in y-axis I need the general merit rankings. See, branch and general merit rankings. After I enter, I got a plot. See, civil, it's around 19,173. See, plots. Computers, it's 8,408, and electronics, it is 9314. See, approx, not approx, it's correctly, because here 9,000 is not there. We'll do, yeah, we can analyze. This is a scatter plot. With the comment I have also put, if you want to see weave it in a bar plot, we can use, instead of plt.scatter, we will use plt.bar, and x is equals to data. Now see here, actually I need to mention df6. I have mentioned df6. The same follows here, because x-axis we need branch of which data, of df6 data, and what is the height, like general merit ranking, it is of df6 only. Okay, now once we have plotted for DSF6, now you see we need to do it for DSF7, 8, 20, 21, 22, 23. Okay, the same thing follows. What we have done for DSF6, the same thing follows. DSF7 dot shape, we'll get the number of rows, number of columns, and we'll weave it. Okay, we have here, see, the chosen college, Sri Dharmasthala SDM College, Dharwad. So first and foremost thing what I need to do is, I need to remove the unnecessary columns. So I'll just use DF7 here and here, like in DSF6 and DSF7, and upcoming all the Excel sheets which we'll be working on. The only change in the syntax will be this variable. Instead of DSF6 I have used, see, instead of DSF6 I have used DSF7. That's what is the change. Okay, I'll drop off, you can see from 25 columns it reduced to 2 columns. Okay, only 2. Next I'll weave. I'm weaving 0 to 9, means I'm weaving 10 rows. If you don't enter 10, it will weave only 5 rows. Okay, 5 rows, and we'll be having left with 2 columns. So I'll be renaming this 0th index 0. Next again next the same. I'll drop off this 0. I don't want this line, this row. Okay, so I'll remove. So from 49 it reduced to 48. Next again I'll weave. I don't want this mechanical. Okay, I'll remove it. 1, 47. I'm left with 47. I shouldn't have weaved this 47, but still I'll show you. From 47, okay, 47, each and every data till 40. Okay, 47 data, everything is ready. After this, see, I have used 6 to 47. Why? I'll show you. Next drop, I'll show you here. It will be a clean analyze. 0, 1, 2, 3, 4, 5, 6. I have chosen, as I told earlier also, electronics, computers and civil. So I don't need from here. So according to index numbers, index position 0, 1, 2, 3, 4, 5, 6. From 6 onwards till 47. So using this syntax, I'll remove from 6 to 47. So I'll be left with 6 rows and 2 columns. Okay, here you analyze, like, see, we don't need this row and this. 3 rows we have to remove. First 0. Okay, removed. Next, see here index position is 0, 1, 2, 3, 4, 0. Okay, I need civil. I need civil, computers, electronics. I don't need chemical. It is in index position 1. So what I will do, I'll just remove. Okay, I'll just remove that. So I'm left with, and the same follows. Only the changes, like instead of DSF 6, DSF 7. Again we are left with this, like the plot for DSF 7 data for all the branches, and like what do you say, general merit rankings. The same thing follows for GSF 8 also. We'll load, we'll weave, we'll drop the like which columns we don't use. Here also the changes, instead of looking at the previous DSF 7, the changes only DSF 8. All the things remains the same, only the syntax and everything remains the same. See, DSF 20, any changes? No changes. Like we'll drop whatever we don't, same syntax remains. See, this is a plot for DSF. This is a plot for DF20. Okay, means 2020 Excel sheet data of KCET. Okay, 2020, 2018, yeah, 2018, and this is the data for 2017, and this will be the data for 2016. Okay, the same thing we have to continue. Okay, uh, see, this is the data for 2020. 2021, first I'll load, I'll see the number of rows, number of columns, I'll weave it. Next I'll drop unwanted columns. I'll be left with 2 columns, which is same for everything. I'm working on only for general merit category. So I'll get GM, I'll number of branches, and I'll see next I'll delete. I'll be finally left with civil, computer, electronics. This is of 2021, and same syntax, only the changes of data. DFT1, DFT1 is DF. I have used DF6. Okay, DF is, I have assigned a variable, simply whatever, we can take anything. DFT, T means 20 and 1 is 1. That's what I have used. Okay, you can use anything you want. Okay, this is a DF2, means 22. Again the same thing follows. This is a graph for 2022 data, and this will be the graph of 2023. This will be the graph of 2023. Okay, once we are done with all the datas, like we had total around how many files? Okay, we had totally loaded 8 Excel files, out of which 7, till 7 we have completed all the, like, scatter plot and everything. Next we have Excel sheet known as all result. Okay, Excel worksheet. So for a proper analysis, after 2023 we have plotted this. We'll use DFT total, the Excel sheet, the 8th Excel sheet which we have loaded. In that we have 2 columns known as year and 3. Totally we have 4 columns: year, civil, computers, electronics, and we have like 2016 to 2023 all the rows mentioning the years. Okay, so what we'll do, we'll plot a scatter plot between only civil department on from 2016 to 2023. 16 it was around 19,000, 18, 20, 21 something, and so on. The same thing, this syntax only we'll use, and we'll plot between different, what do you say, different branches. Next I've done it for computers, see, years and computers. Okay, next for electronics I have done. Okay, after this using the polyfit function, what we'll do, for this particular data, line of best fit will fit a line, like line curve fitting or line fitting, we can say, will fit a straight line. Okay, so this is a syntax. Coefficients is equals to np dot polyfit dft total. Dft total is the variable I have assigned to the Excel sheet of all total. As you can see here, I have assigned this for all total Excel sheet. Okay, dft total. So the next thing what we'll do is, say I've got the scatter plot. I got the scatter plot for all three according to the years and particular branch. Here what we had done earlier we had done a scatter plot for all the three branches and general merit category. So here what we'll do, we have here like years 2016 to 2023, and I have chosen civil. This is the ranking. Okay, 20,000, 30, 40 till 90,000, everything is the ranking of civil category. And see, here it will be 90, here it will be 9,600. Okay, so here it will be 15,000. Okay, next what am I supposed to do? Line of best fit for all the three datas. So first we have done it for civil, right? So what we'll do, a polyfit, using polyfit function, dft total, year and civil. Okay, next line of best fit, the formula for line of best is slope into dft total, year plus intercept. Next we'll plot, first we need to plot the scatter plot, dft total, year, civil, and label is data, like this one, this particular, and it's also mentioned here. And for plot of line of best fit, see I have chosen color as red. Line of best fit, it's coming here, label. So this is the best line of fit for this particular data. For this civil data with respect to year, this is a best line of fit for this all the particular data. Okay, the same fashion follows all the three, 1 2 3, all the three it follows same. Whereas we will be working on computers data, like computer branch. Okay, so this is computer. Instead of, what is the change, it's very simple, the code and everything remains the same. Instead of civil I have used computers. Okay, everything remains the same. So once I've scatter plot, you can see the scatter plot. Okay, this scatter plot, you may think this should be same with this. Yeah, it will be same, no change. Yeah, the same scatter plot. Okay, what am I supposed to do? A fit a line of best fit. So for this particular line, now this red color line which you are weaving is the line of best fit for the computer branch data. Okay, the same fashion follows for electronics also. Same code, and all the three lines remains the same. Instead of the other branches what we had mentioned like civil and computers, will mention electronics. And okay, the first we have chosen scatter plot is plotted. Next we'll plot the line of best fit, so line of best fit is also plotted. Okay, after finding the line of best fit for all the three branches, the next thing, like in only one figure we can analyze all the datas. Okay, so for that, dft dot total dot shape, what dot shape does, it gives number of rows and number of columns. We have 4 columns and 7 rows. See, I am weaving it here. Okay, I have mentioned 10, it's okay, the maximum limit only it comes, right? Dft total, this is a variable what I have said, dot head, and I'll weave using data frame. What we can do is, This is what I want in x-axis, and all the three columns should be viewed. Civil computer electronics, and I'll plot it. Okay, kind is equals to line. I have given a line chart, and fixed sizes like 9,8 is the size of the figure. This you can see, this is the rankings 20, 40, 60, 80. Civil is represented with blue line, orange and green line. Electronics with green line, computers with orange. And this is the particular years 2016 to 2023. Coming to computers, we can see there is no much change from 2016 to 2023 for that particular chosen college. Like I have chosen STM Dharwad. For computers, there is no much change. Also, you can see here it is 8,000, 8,000, 9, near to 10, 8, 8, 9. There is no much change. So we can see there is no much change. Through this graph, we can analyze the data from 2016 to 2023 very easily. No need of viewing an Excel sheet or anything. Through this plot only we can see there is no much variations in the computer branch. So this represents the computer branch over there is performing well. The placements may be well, because the cutoff almost stands straight only, because it's looking almost similar to a horizontal line. So there is no much variations, and it's good for that particular college. The computer branch, maybe it will be performing good. Coming to electronics, is represented with the green line. So we can see from 2016, 2017, 2018, 2020, 21, 22. There are 2016 to 17 there is no much change, but 2019 there is some decline. Okay, some decline and some improvement, some gradual changes, some changes. Okay, up and down, up and down. So it might be also performing well, whereas in some aspects they may be low or high. That's what is the fluctuation between the years and the rankings. Okay, the cutoffs. Okay, coming to the civil branch, there is a huge change. You can see from 2016, 17, 18, 20, 21, 22, 23. Okay, according to the cutoff of civil branch of that particular college, we can see from the data only, we can see that the branch may not be performing well due to some reasons, or the placements may not be going well, or some maybe other reasons. Okay, so the final output, what I want to say is that instead of looking at this, yeah, it's 1973, coming to an analysis of all these readings, you can plot using data frame all the branches. I can include much still branches, and I can see what is the analysis from of all the 7 years what I had taken from 2016 to 2023. I'm telling 7 years because excluding 2019. Okay, so I'll get a proper analysis, I'll get a proper figure, like which branch is good, which branch is performing well, and everything analysis I'll get. Okay,